My name is Soham Mandal.
Hi, my name is Audrey Transue.
My name is Grace Hercik.
It's Jack Lorence.
Maya Fulton.
Akshay, Balaji.
Patient caregivers that perform electrocardiograms or ECGs on their patients often struggle with keeping the 12-lead system organized and untangled, often exacerbated in urgent settings such as pre-hospital emergencies and transfers from EMS to a trauma team when time is crucial to care. Our proposed solution to this need is an ECG lead organization device that utilizes extension and retraction to waive the need to untangle leads every time they are being used and provide storage organization between uses.
Our ethnographic efforts span a wide variety of healthcare settings and providers. To name a few, we've been fortunate to meet with staff at a Level 1 trauma center, a local EMS agency, emergency medicine faculty here at the University of Pittsburgh, and a participatory activity on cardiac floors and ICUs at Canonsburg Hospital. With these efforts, we've been able to identify two key archetypes: nurses and EMS staff.
Once we defined our unmet need, we began rapid concept prototyping to create as many design ideas as possible. This involved sketching, which included our various design ideas, and foam core prototypes with functionality. Using our prototypes, we specifically talked to registered nurses and trained staff at Weiser. They interacted with and evaluated the prototypes, during which we conducted a series of questions to assess their design requirements.
The input that we gained from healthcare professionals guided our minimum viable feature set. The features we identified include the ability to have multiple retractable spools in one device, a portable and lightweight device, and adaptability of our system to different lead lengths.
For hazard and risk analysis, we built a risk summary and an FMEA. We identified hazards like tangled or compressed leads delaying care, insulation breaches exposing conductors, and patient entanglement.
Given the risks we identified, we aimed to develop a design that minimized and controlled as many hazards as possible. For our design, our system uses individually coiled leads with each lead wound together through its own spool. These spools are linked by a connector piece. For convenience, V1 through V6 are housed together in a single casing, while each limb lead spool is placed on its own casing to preserve full range of motion during extension. To retract the leads, the enclosure is attached to the connectors, allowing all the spools to rewind simultaneously with manual rotation of a handle. Because cleaning difficulty was a key hazard determined, we designed a system so every lead can be easily removed and each component can be cleaned separately, improving overall safety and usability while mitigating risks.
We completed both verification and validation testing for our ECG lead organizer, and all tests met our acceptance criteria. For verification, we confirmed that the device is compatible with different ECG lead brands and lengths, while maintaining similar lead slack with device use. The device also remained fully functional after simulated drops at bed and stretcher heights, and met our portability requirements, weighing 113 grams with an end-to-end length of 10.4 centimeters. For validation, clinicians use the device in simulated clinical scenarios. We found that the ECG setup time was reduced or equal to baseline, and 100% of users rated the device as a better organization solution. Signal quality was preserved, with 100% of users confirming that the device does not damage leads or distort signals. Additionally, 13 out of 14 participants agreed that the device is easy to use, portable, and easy to clean, with 93% and 100% of participants assembling and disassembling the device in under 5 minutes respectively. Overall, these results demonstrate that our device meets both technical and clinical user needs.
Our team addressed the unmet clinical need of disorganized and entangled ECG leads by designing and validating LeadAlign. These efforts ultimately led to the filing of a provisional patent application supporting continued development and future clinical translation.